All right, so what's here? Last day in circular motion, we had all these little formulas we talked about, right? Centripetal acceleration, centripetal force, right? Linear motion, and right. Remember, this here was what we call angular velocity, right? Okay, we had all those formulas. We said during a vertical circle, right? How many have in there, right? But during a vertical circle, when the object is at its lowest point, centripetal force was weight and tension, right? Centripetal force and tension minus weight. Remember that? And we also said at that point, tension was equal to centripetal force plus weight. And at this point, tension was the largest. Are you okay with that? The tension was the largest at that low point. What happened up there? Tension was the up there tension is the smallest, right? Yes. And well here tension equals to weight. Right? I know we missed the diagram, but all the formulas there, right? And then we look at a horizontal circle. We look at a horizontal circle and we said that right? We said that if I have an object on a string moving in a horizontal circle, Marquis, moving in a horizontal circle, the tension. Yeah. Right? Tension was equal to the centripetal force. Right? Why it is the weight have nothing to do with centripetal force there? Because centripetal forces towards center and the weight acting right, and the weight is acting vertically downwards, right? So the weight has no effect on the horizontal motion. Okay, but the weight acting vertically downwards, right? Right. So those are the things that we did last day. All right. So today we're going to some part of papers in this, right? I think we did one alone, right? What's the year that we did?
This one is not nice enough.
Okay. Check out if we did this one.
Yeah, we do that one.
Okay, we did this one?
Yeah.
Yeah, okay, nice.
Oh, yeah, it's up.
Probably that's one.
Last year, I'm not so talking. I can finish it there.
Oh, yeah, we come to that conclusion already.
Last year, bro. I wasn't in last year. Exactly. Don't worry. Don't worry. You can't go there. You can't go there. I'm saying. There you go. $10 next time.
Hold on, they're trying to find the Alright, let's try this one here. I don't know the year. It is how old year? 2002, 2003. Let's try this one here. Part C and part E.
But
Also, I use
So you can set it, let me chat, that has to probably.
Take a picture and then.
Camera, glasses.
Take a picture and send it. Part C and part D. So talk a little louder, please. Vanessa, you said going somewhere now. Wow.
Wait. Wow, that's a good
Alright, so let's try part C and D, right? Yes, part C is the one with the star and so. I find it slow down.
You don't know. You don't know.
Ready? Right, pay attention to this type of circle and all the quantities they give, right? Horizontal is the one that's going. Well, check and see what type of horizontal. Yeah.
What I'm already done,
Well, you can create it like this.
like
You need string at an angle.
Like, yeah.
It can be. Oh yeah, we have plenty questions. Right, after this, to finish module 1, we have gravitation and kinetic energy, right? What are you able to finish it up next? And really holiday to do in module 3.
So, for pure answer, you sign trains.
That's holidays.
I get six in my exam. I get everything one you want correct. Except tricks.
But if I show you we are not American, I'll make a board. Yes, I do forget.
I shut, I not ship it, I didn't know it.
And now we have feel I could be like 16.
And the universal market.
When I was not here, I've seen stars. I would not comment on technology with that. No, like actually, I would not actually comment on it.
That's what cause you own thing.
Yeah, I feel like thing that.
Would you consider yourself going to the US?
Are you ready?
Hey, I just want my diagram with it.
So we do this.
No, try to be question similar.
Not like.
Better than similar.
That was not good, sir.
No, no, I think.
So.
Trying to get that. Huh? No, I didn't want to take the book.
So you can smoke bags. I was. You win.
Now we have,
You played the other one.
we are doing.
See.
Are you ready?
Yeah, you know.
Alright, so that's another diagram showing the info, right? They give you a small mass of 0.5 kilograms that is kind of a string,
So generally board now.
If
You do feel anything.
and it's a horizontal circle.
Now, serious,
Okay, I'll work it out just now, I just want to put it to start, I don't want to do the whole thing. right? Let's use gravity at 10, right? So therefore, what will the weight be?
Um. 10 by 6.
10 by 0.6, which is 6, right? That's 6 Newton. Nice. They gave us the radius 1.2 meters. And they said that the string will break if tension exceeds 60. And tension always acts where? Towards the right. So here what you want, right? They give tension. What is the greatest frequency? So they want you to find F. So you have to think about all the formulas that we did last week. F is equal to what?
1
All right, but we did the next one as well. F is equal to what? F is equal to a half M. And if you have next formula with it, with F minutes. Right.
Yeah.
Right? I gave you a next formula, which is omega over. Right, omega over 2 pi. Nice. Okay.
That was
Omega is 2 pi F. Can we have that? Can't do that, right? So the problem is we need to get what? Omega. Right? So how we get omega? Right? In a horizontal circle, in that scenario there, what is the centripetal force equal to? Centripetal force. No angle in this case because this is one like that, right? Yeah. Anybody remember in this horizontal circle, centripetal force equals to what, Sylvester? Sylvester, whoever your message in the man get right to that. Centripetal force equals tension. Right? Tension is equal to 2.1. So sorry. Wrong question on what you think. 60 newtons, right? So if we know the centripetal force, we know the radius, we know the mass, right? Can we find omega? Shanisa, can we find omega? What the formula are you gonna use? Centripetal force is 60 newtons. What are you gonna use? No, remember that scenario only works if the string is at an angle. In this case, the string is horizontal. So what's the formula since they know centripetal force is 60? Anybody can help us? What are you gonna use to find omega? Please, what are you gonna use? Check all the formula of the centripetal force. See which one has omega in it.
So, you could use. Say, we have.
M, not V in this case, M
Square.
omega squared R. Okay,
Yes, sir.
I tell you, you have all some last week. You have all for, but I can't log in last week. Log back out one time. Just everybody, all right, thanks Sylvester. What's that speed there?
Yes, you can answer.
All right, so centripetal force is equal to M omega squared R. Please solve for omega and tell me what you get, right? Online. Solve for omega and tell me what you get, right? Right, solve for omega and then work it out, right? Any answer for omega?
I find some of the chance.
Katrina get 9.1. Right, and then go right ahead and find the frequency. Right, frequency will be 9.13 divided by 5.
Very points wrong.
I think master give it up.
The master one.
Master the object.
Oh. I knew that. That's the goal.
I know that's master. Right, Katrina got 1.47. 1.45. 1.45. That's okay. Let's go again. Next one.
Oh, omega one. Okay.
Let's go again. Part 2. I mean, part T.
I like that one now. What is answer? I asked you to let me do this tonight. Answer.
But then we have one more week next week, and then if we have we get December, and then we have that. Those 6 sessions, right?
What is the last hour?
Last. What is that? The 18th.
So we are.
Second time table, right?
We are going second weekend vacation, you know. We have a dragon boat thing. We are doing.
Oh, yeah.
Lord, keep them up to this. Okay, can you read it? I can't see.
Right, part T now.
Hey, yeah, the part 1 and 2 for part B.
Huh?
Yeah, the part 1 and 2 for part B.
Gosh, boy, this all you doing, everything here. Right?
Not us.
How be? Where are you coming?
Oh,
What's the come from?
6 ago.
Did that again, true?
But then he did it. Okay. All right. It means so.
Huh? In a vertical circle.
Oh.
One game we go to software. Yeah. Awesome. Yeah.
The next game, we'll tell you what's up Friday.
Yeah, it will be service. They find a very weak out.
We have to have.
Minimum tension is on top, right?
So, yeah.
Minimum tension is on top, right?
Huh?
Minimum tension is on top, right?
Minimum is on top, yes.
Very great.
Yeah, because guess why? But he wasn't join our group.
You know, you're cool. So he did not.
Yep, that's how the one team.
Every game I went, we straight together.
So he have one boy.
Yes,
With a one boy. But he liked it when I'm such a good boy.
I swear I see.
Never like. He wanted, but he liked our, I don't think he didn't get the opportunity if we are wrong there. But I think what he. Oh.
I think they do that. If you want to get it, something is like, yeah. The footballers have just been jumping up on the head.
Right, take your time, draw a little circle, highlight where is minimum tension and then work it out, right? Well, do your explanation. Alright, take your time, I mean, we'll be going again, asset one in group for those who working fast.
So I was.
I want to go.
See if they know.
No, yeah, you got it.
No, that's the next one. After the song, let's do this one. Well, I don't understand board, right?
Vietnam.
Boy, that's not boy. I just joined the little circle, boy. Right, so. Right, do your explanation for where is max tension and where is minimum tension. Right, and then focus on the calculation, right?
B equal to RW. Yes. Huh?
Oh,
B equal to R.
yeah, you can do that, or
Is V.
or something else.
B is equal to.
Right, so we have a mass 0.6. We have a mass of 0.6 kilograms. It's rotated at the end of a string, constant speed v, right? Constant speed v. And the radius is 1.2 meters, right? And the minimum tension 2.1, right? Let's see how this will look.
Omega wouldn't change it. So omega wouldn't change, right?
Right, so, right, yeah.
Omega wouldn't change, right?
Yeah, why is that a different scenario now? It's a vertical circle. Right, but where does minimum tension happen? Where does minimum tension happen? Up here, right? So how do we find tension up here? Tension up there is what?
Bendix principle, part of the contingent.
Just lower it up, because I still recorded. right? Yeah, so tension is what? Here, tension here is weight minus centripetal force.
Hey, that's a complete,
The other way around, right, Claudia? It's centripetal force minus weight, right? Well, remember that? Remember, right? Remember that centripetal force is tension plus weight. So therefore, tension is centripetal force minus weight. But suppose because they wanted you to find velocity. Hey, I'll take it off, yeah? But that's a multitask watch here. Right? So tension is what? Centripetal force minus weight, right? But because you want to find velocity, which formula are you using? mv squared on r, right? Right? And we know that weight is 0.6 by 10. Right? And that's it. Plug in everything and solve for V. Minimum tension is 1.2 or 2.1. And R is 1.2 by 6. Right? We arranged, tell me what all again? No. Work it out. Right, so whenever you're choosing the centripetal force formula, you're using this formula if you need the B, or you're using one with omega if you need omega, right? Oh yeah. Hey, if the camera doesn't take it over.
No, I visualize the product, somebody.
Work it out and then we have the next one, right? Online, you can message your answer.
Why is it put there? Why
How much you all got online?
That's the one which been last. No, last year.
Right, so message the answers to me, right? All right. What you all got online? Look it out quick. What you all got for this speed?
So you can't see it there, it's the balance. Oh,
Okay, third post. Right, message the host there online.
That's not it.
Katrina, you work it out? Yeah. Right, it's not 3.77. Yeah, 3.77. 3.77. Yeah. Right, checking the group as the next one. Right, we're doing the part B, right? We have to find the gymnast speed at Q. Take a little read. What? Well done. What type of circle in gymnast creating there? A vertical circle, right? Right. Part one I might have to help you with, but it's for 5 physics. Right? They want to get the speed at Q. Right? Speed. You want to get the speed at Q, right? You have to think of what's happening from P to Q. Form 5 physics stuff. Right? Katrina, I wouldn't be able to remember to send in messages to the host, right?
Hey, make sure Vanessa can hear. Vanessa, go on, I have that.
What I say here? Yeah, well, yeah. How we getting the speed?
So, well, we
What
see
the-
F is equal to T minus W.
Now we don't have all that equal here. We have to do something before that.
So it takes out.
No, this is think in terms of form 5 physics, right? Think into the energy. What is happening from P to Q?
So,
A decrease in.
A decrease in potential and a gain in kinetic, right? So whenever your potential changes to kinetic,
A half of this square.
okay? But what's the formula we use? What's the formula we use when the potential is being changed to kinetic? What we use?
MT is equal.
Oh, by the way, I have the other question, right? The question that we're doing now is 2009, right? 2009 number 4. How do we do it now? Right here. Whenever there's a change from potential to kinetic, right? MGH, I'm not sure if you remember this formula, right? But MGH is equal to
Half of this square.
the M to cancel,
So, yeah, yes, sir.
and you'll get the square root of 2GH. All right? So, see if we can find out now. See if you can find the velocity using that formula, and then try the rest. Part 2, part C. Sylvester, why not working it out? Question on the group, yeah, use gravity attack.
No, not yet, because you run for France.
Yeah, 14.14.
How much you get? 14 point.
14.14.
Yeah, use gravity at 10 $. Katrina, you remember the message you host, right? So I'll see your answers, right? Right, but I have V is equal to 2 by gravity 10, and height is what?
10.
10. Nice. How much you got?
14.14.
Alright, go ahead, find part 2, and then find part C. Take your time, find the angular velocity, where's that,
But
come again, that's earlier. Come again, angular velocity omega. Check your formulas. See what is omega there. Sorry. Come again, part two there earlier.
equal to parenting.
Yeah, but we do not see, we just find V, yeah? Right, V is equal to R omega, so omega is V on R.
I drop it for you. You see that?
Yeah, but why you gonna use omega is 2 pi and T for? You don't know T?
So we are remember it's bonus versus. I feel like you're right.
Very pronunciation. I didn't see it.
Okay, so I agree. Am I teaching?
I
R is what? R 10, right? Right, so the angular velocity is
Yeah, what is it? Hey,
Hey, Katrina, yeah.
just appreciate. Appreciate.
Marquis, you're got now next part. Wait,
What that means was like.
next part, part C, part C. Right, draw free body diagram of the forces acting on the gymnast at Q. What are the forces, what are the forces, Sylvester,
Yes, sir.
at Q? What are the forces acting on Q? Which is weight, nice, and what else? Okay, well, it's negligible, so I'll leave it out, and we have tension. Right, and the resultant of these two is your tension, of course. Very good. Go ahead. Right, so that's all you have for part one. Part two, calculate tension. Calculate tension there, Vishy, and finish. Calculate tension.
Part three.
There is no part three, so part two.
No, you can't put that around now. The question really is,
I see part two.
you're not in big guy.
Master 75, right? The master 75. Second, yeah, but those things negative. Yeah. Wait, excuse, can you do one question for the day, please?
Wow.
Not even one, do parts. Do C part two. C part two, tell me what to do for C part two.
You know, it's not really I'm gonna be for you because every time I try to-
It's so loud, boy.
every time I try to do it, I get it wrong. I'm pretty. I learned in was a kid. You get that. Hey, where do you mean you guys come from? Uganda,
Oh my god.
cartel, Latin cartel. It's something cartel. It's crazy. It's crazy. Okay, sir. Salutes MB square on R. MB square on R
Partly, yeah, you're getting there.
plus weight. So you try to find tension, right?
Yeah.
The MB square on R plus weight. Actually, guess the main correct on like feet.
You didn't get it correct on the, I wrote it out. Watch P every class, they're talking. I say anything, I just say you talking. The level of, because that's all we have, we have. If we use 2 pi and t, how we get tension, how we get period. Right? Because when my part one becomes B, so you know V and R. Right? Online you can message the answers.
Where you get where you get
That was about just now.
smarts? Where you get?
Oh, smarts. 22,
22, 49.
21.
I get 41.
Online, any answers? Keelan, you working it out? Keelan.
So what you got? Yeah. Illustrated? The it is seven.
I would just say by 14.14 squared over 10. You can read it that way.
No, when you're ready for result, the ground force equal to
Yeah, right. Introduce equal to CF minus something.
Right, so what's here?
And CF will be MP squared bar.
Last part, right? C part 2. You all done online? Mention any answers?
Why would you cut the velocity?
Right, so they asked us to find tension. We know tension is centripetal force plus weight, right? Centripetal force plus weight. And as Matthew said, centripetal force is mv squared on r. And the weight is 75 by 10. Nice. Okay, we know the mass is 75. The velocity, we found it already. 14.1 squared, and the radius is 10. What's the radius?
10.
Plus 750. What is that?
So I use 14.1, so I check. Alright, so, 2241.7. There you go.
But just
2241.1.
I just use that, right? 2241. Am I just there?
Yeah, I get that. Yes, sir. I know it before.
Wait,
We had on that gun where they give us weed.
Okay.
Uber.
wait, Uber. Anybody online got up?
Yeah.
Sorry,
42.5. You probably use a different value. B.
Hey, Lee, that was the best done. Maybe not yet.
Katrina, just check and see if you use a different value for. Grab. If you grab TL. 10, okay, and what you use for B? You get an example, you get an example. And you get. 2, 4. And what you use the exact value? Every single. Hold on, I'm gonna look at you. These are gotta be. We just don't have practice when you use sign for some time.
David.
Yeah, I got 2241.1 if I use that value, right? Right, okay. Alright, next. Next one, 2014, number 4. 2014, number 4. That's the last one we do it, right?
That's not your usually.
2014, number, no, gravitation up.
Oh, God.
Why do you want question, finish?
I need to ask
Finish, I feel you get one before we are.
And then. I mean, what this is.
Huh? I know, ask you that number. Number 4, 2014. Come on, the last one. Number 4 is 2014. Everything. Last one. Hurry up, 10 minutes.
Now you guys think last then.
Now, yeah, hurry up. Yeah, 15 minutes to do it, that's correct. Second into 2014, number 4. Last one, then we'll change it to 7. Faith to go, I'm begging you, faith to one question of please.
What else?
That's the best way you can find out.
You can go ahead. No. Come on.
You know, I'm trying for 3 meters.
From trees, yeah. I would not do that. I was when I'm bad, I'm Sarah play so you can see what actually went on.
Most of them go.
Team was six. Team was six.
But I come pay for you.
Yeah, that's a long story. So,
I hurry up. Explain why a particle moving with constant speed along a circular path has acceleration. Pete, explain that. I give you the easiest part. Come Pete, I give you the easiest part. But you're talking whole. Explain why a particle moving with a constant speed along a circular path has an acceleration. Right.
By definition, acceleration, that change of velocity, by definition is displacement over time. And because because the direction of forward head will change, the velocity technically changes.
So as the object moving with a constant speed in a circle, direction always changing. If direction changing, then the velocity will change, and if the velocity changing, then the object has an acceleration. Nice. Part two, you can leave all that, because yes, I didn't. The part, right? Oh yeah, try part B and C. Try part B and C. Yeah, take it to the left hand side. Oh yeah, do all actually, do part two and then pass. Wait, if you like it, do both around people as well. Hurry up.
Yes, yes.
Go back. Wait.
Yeah,
Actually, I better money now, 100 and ups.
I bet not 1,000 minutes.
Nah, I'm on the minutes. Gotta pay. You gotta pay.
I
Yeah, this year.
it's so much easier happening down now.
Oh, yeah. Oh, God, how much?
Daddy boost
Yeah, he's basically the little ones so you can't see them.
Go, once more, I'm maybe twice. Good.
Good job.
So I can help the man out.
I was innocent. Did the guy punch? Did he read? Because you were just pouring that there, right?
And nobody's understanding shoots. Nobody's.
Nah,
Nah, that's a problem. Sometimes you like a few shots.
we have some other you
Yes.
S
Right.
yeah, in our book.
Yeah, and then tracks.
Yes.
Are you ready?
If you want to take a cut, then you take off this one, but then this one.
Oh yeah, so the first part,
Right.
the part in part two with A is equal to what? B squared on R,
Yes.
right? And we know that the left hand side MS minus 2. So the right hand side will be B squared on R, so that's MS minus 1 squared on M.
I thought you said you're doing A part 2.
Yeah, well, all they're doing that is I just doing it out fast there,
You know, we-
right? So therefore it's true, right?
Yeah.
Right, do part B quick,
I tell you this in the rest of the class.
right? Do part B quick and then we have parts. Part C really is when doing that over and over and over. Part B might be a little different.
Erase that.
Oh yeah, side part B then. Huh? No. Man, it's more. Huh?
Whereas was on here, it's like- When you go.
No.
You walk. But whereas one here. First thing.
Oh, that looks.
No, when you go Benedict, so we-
I lost 2-1 or 3-1 or something. That's what we said.
9-1.
But
That's stupid, man. Whatever.
I'm sure.
You want the next one?
yeah.
You get to the next one. Yeah, yeah, contract, right? Sure, you know, in the US, right? Right here. You know, in the US, right?
Child.
Sure.
Think about it, speaking in the sugar, it's.
That's about really young.
I just always thought he was great about them. Yes.
Ready? Right, next part is said that a recent cow mass 500 kilograms. Breast, oh sorry, front breast, and accelerate at 6 meters per second along a straight road, and then it enters constant speed 2, right? Right, so this is going to introduce something called banking, right?
That's my yellow.
Yeah.
We're gonna bust in here. Replicate of shape. Go give it all my so here. Yeah, I got you. Not stay up on.
Oh, you know, see, it's yeah, I am like, I think it's just stuff.
Alright, so question said that a recent cow mass 500 kilograms, start from rest. So the initial velocity is 0. Right, you start from rest where the initial velocity is 0. And accelerates at 6 meters per second along a straight horizontal road for a distance of 150 meters. Right, so they travel along this distance here, 150 meters.
Okay.
So you.
I know, I think about that. Let's see, me actually.
The ball behind the ground.
What is the magnitude and direction of the resultant horizontal force? Hey, what is it? What is the magnitude and direction? So what's the diagram? So the car moving on a straight and then it goes to enter the curve. This concept here is called banking. Right, so like you're driving on the highway and then there's a little curve by gas below there. This is called banking. Alright,
So, what do you think service do?
well, it's technically the same thing,
Or because.
right? At an angle.
That angle,
Circular, yeah, it's circular. Straight and then it's like.
I thought banking was like, you know how the segment track is?
Right, but it's the same thing, it creates a circular path.
Okay.
It creates a circular path. So you're traveling in a circle and it's an angle. But banking is moving at a circular. And I think that's circular.
I just see.
Alright, so here we have the car and they want us to, right, so here what they're asking, right? What do you think they're asking here? What is the magnitude and direction of the resultant horizontal force? What is the horizontal force we're talking about? Acting on the racing car as it travels around the
And,
curve. What is that horizontal force we're talking about?
yeah,
Sylvester? Yes, right? So they're asking for CF. So they're asking for centripetal force. The centripetal force is that horizontal force talking about. But anybody can tell me exactly what this force is? The question didn't ask that, but I just asked it. What is the force that keeping this car along the circular path?
skin.
But just drag it closer, it's not dragging, you're on the ground. What is the force keeping the car? Think about it. If you do have that force, the car will not stay on the curb.
Traction.
Friction. Yeah, I'll take that. Friction. Right? Friction. Okay? So technically, you are trying to find the friction, right? How you find this again? Centripetal force. Centripetal forces.
MV squared over R.
mv squared over r. And we have m.
Yeah,
M is how much?
I0.
And we have r.
Yeah.
So the problem is we do have
B3.
the velocity here entering here with.
But what is, we have CR,
Huh?
we have CR.
That's what we're trying to find.
So, then we can use that one.
Well, check and see if we have all this still, you know. We have all this still.
So tell me how to use your laws of motion to find.
Right? Right, so you mustn't say that, Vinesh. That's smart.
I must say.
He was telling me something Wednesday. Right? So we have U, we have A, and we have S. Can we find V? What's the equation of motion? Which one are we going to use?
E squared.
So we have V, A, and S. V squared is equal to?
E squared plus half AS.
Very good.
Yeah.
So it's 2 by A by S. How much is that? But actually, you do have the square root, right? Because you want V squared here.
2 times 6. That's 6.
Yeah. Acceleration is 6. Right? And then you plug it in here. So that's 500 by 1800 all over 200. Work it out, tell me what you get.
6 times.
They can just cancel it and you'll get 6 by 5.
Yeah. The 300. 300.
Sorry, it's 45. 20 that's 9, yeah?
Push it, yeah.
45 on.
Yeah.
You'll follow went on,
Yeah.
right? But again, you needed a diagram.
So I got the.
How I get what V? I use our equation of motion to find V. Okay? We check out online. Anybody gets? Dylan got it. Very good. Right, well, I didn't. You didn't really have to find that value, right? Nice. Good job, Dylan. Dylan, thank you for saying that. Good job, Dylan. Dylan is in school or?
Yeah. But I would think, start.
Katrina, y'all got this, Raj?
Yeah, I just got.
Huh?
Yeah, I just got. Sometime.
Yeah. Alright. Anyone else? Oh, yeah. The last part. Might as well let's go out. Yeah. Do part C now, we're about to start the next thing, right? Just do all part C and be done. Do all part C and be done. Part one, you're quite up to that, so let's focus on part one and two, just part three afterwards. Right, that part now. Just parts. Right, if you do want to write back part one and two, you do have to write it short, right? The main thing is part two. Who's that? On the board. I don't know. I don't know.
This is. In my opinion, we have been able to serious.
Yeah.
Yes. Well. Here. I will. Okay. Serious. Close to something. Something.
Right, all they want is the forces action. Hold on. Dinesh, right, in what position along the vertical path where the string most likely burst? At the top here or at B? At the bottom, right, and the path will be what? The path will be like this, right? Why? Why will it most likely burst at B? Most tension, very good. Right, and do part three now, and you're done. Right, find angular speed. Right, based on the info you have there, who I pick one answer, Kizana. I pick one. Based on the answers, based on what it gave us, Kizana, how will you find omega? Look at how they gave you, right? They gave you the mass, they gave you the length of the string, that's like the radius, right? And they gave you max tension. What's you going to use to find omega?
Omega and the loss.
Yeah. Hi, everybody, let's go college it up. Last thing I'm done. Both of them yes. I don't think about it. John would go down.
Yeah.
Yeah, who's last one?
I don't think.
That or your concept.
For me.
And
Yeah.
concept.
No, I see not what type of school, but when you went to the past month or so. Really?
No, no, I don't know, that's the last.
Oh yeah, final mega be done, final mega be done, online final mega, that's the chance be done, right? Technically, we did this already, yeah? But he's making that final mega.
So it could be explained, gonna be done.
Last question, right? Take your time. Remember, it will break at the bottom, right? So final mega. What's the relationship we using again, Olia? Tension is equal to what down the bottom here? Centripetal force plus weight. Nice. And you know what the tension is? I forgot the question. Tension is how much? 20, right? Centripetal force, since you want to find omega. Which version are you going to use? M what? M omega squared R, right? And of course, weight is M by G. Right? Plug in your values. Please don't use 500, use 0.5, right? What R? What's the radius of cilia? 50?
So that's centimeter.
0.5, right? Plus 0.5 by 10.
Yes.
Earlier, it's not always 10, so you have to pay attention and see. You have to check and see what G is, right? Sudana, Urban. Follow why I use this. We're not sure about. You sure? Huh? Oh, maybe by 1,000. So you'll get 0.5. Yeah, the weight will be 5. Right? The mass will be 500 divided by 1,000. Huh? Do the next, could you do the next line up again? Answers online for omega. Any answers online? Very good. Okay, moving on.
So. Go ahead.
That's right.
That is.
7 point. Right, 7.75 radians per second, right? All right, nice.
So you can send someone like this, we got.
Yes.
Yes, sir, yeah. Now, that's
It has more than,
So first F5, what's F5?
it has more than 20.
Alright. Well, it's not limited.
No, no.
Yeah, I mean.
Yeah, sure.
Yeah, well, I was gonna be so.
Oh, yeah. Oh, then you know,
No, it's not a phone. This one is just
Alright,
games night in the gym.
then you all, yeah. That was posted.
And come on.
Oh wait, I didn't record this last? Oh,
Come on, me.
okay now. Yeah, right, online, that's the day, right? You can log out. How do I stop this? I don't online, you have to log out, right? In order to see, the stuff on here.
You know.
Stop.
Yeah, yeah.
Before I got one note, a section. I never went up class in my life. I never picked up a Caribbean book in my life. I don't know how I feel about it.
Something will go somewhere.
Okay.
Alright. Head up, switch up floor, right? Head up, switch up floor. Online, your hand.
So it doesn't go on.
Alright, so today we're looking at switch up floor, right? No, I don't want to believe that. What you guys are here? Come on, finish.
You go questions.
Alright, so let's take a look at switch up floor. Right, I gave you the laws in your little notes I gave you, but I just want to focus on the laws and loop analysis now and then start the question, right? Alright, so let's take a look at, how you spell this name again? T. You know what? That's towards something else, you know, to each as well as. Huh? Yeah, it's towards, yeah, it's 2H and 2F, right? So we're looking at the first law and the second law, right? So the first law basically push up, so the recording. Only one side difficult.